All right, I now would like to do a few demonstrations whereby I want you to calculate the friction coefficients for me. So we're going to put a particular object on that incline, and I'm first going to raise the angle until it breaks loose. So you should be able to calculate what the friction coefficient is using the equation tangent alpha equals mu s. And the object that I use for that is this box. In this box is a little weight. That's not very important. It makes the whole thing 361 grams. So I want you to know that the weight of this object is 361 grams. I'll write it down for you here. So the mass of the object is 361. I'm sure that the uncertainty is at least 1 gram. You have to trust me when I give you the angles. I'm going to increase the incline, and there comes a moment that it will start to slide. I'll give you the angle, and I want you to calculate that friction coefficient. So we'll do that first. There we go. It's now 10 degrees, 11, 12 and a half, 13, 14, 15, 16, 17, 17 and a half, 18, 19, 19 and a half, 20. 20 degrees. It starts to slide at about 20 degrees. Write that down. Now, I'm going to do exactly this experiment. Put a rope over it with a pulley and put M2 on this side. And now I'm going to load down M2 to the point that it starts to slide uphill. That should allow you to also calculate the friction coefficient. You have all the tools for it, because once you know that it is just at the point of braking and going uphill, you know that that equal sign of that equation holds. And so you should be able to calculate the friction coefficient. Would you find exactly the same number as you find from this experiment? Not very likely. You have to think about that for yourself. Wood has grain, and the grain in this direction could be very different from the grain in this direction. But it would be interesting to compare the two numbers to see how much they're off. So I'm going to put here this rope over here, and I'm going to set the angle now at a given value. So this is now not negotiable. I set it at 20. I could be off by half a degree. Again, you see it wants to go. We just saw that at 20 degrees it wants to go. So I prevent it from going, and so I'm going to put a little weight on here. Now there is 100 grams, and it's not going. It's happy, and it's sitting there. A is 0. That condition isn't met, and this condition isn't met. So now you must write down in your notebook that alpha now, it's an independent experiment, equals 20.0, maybe plus or minus 1. I think it's about 1 degree accuracy that I can do. Okay, I'm going to load here more weight, more mass, I should say, at M2, and I'll give you the numbers, and when it breaks loose, you will see it, I'll give you the number. Now, I've done this many times, believe me, and the breaking point is not always at the same mass. The mass could differ by 20, 25 grams easily. So whatever number we're going to find for M2, I would say you should at least allow an uncertainty of about something like 25 grams. Just because I've done it many times and I know it could even be worse at times. The humidity could change in the room, and that could change the friction coefficient. Okay, we have 100 grams on it. We have 200 grams on it. 250. 260. 270. And it goes at 270. Did you see it go? It started to slide at 270. So at 270 grams, I met exactly that condition with an equal sign. That should allow you to calculate the static friction coefficient, and you'll get a chance to do that in your third assignment. When I had this thing up here, and when I was loading this down, making it heavier and heavier, I hope you realize that at first it wanted to slide in this direction. So at first the friction was in this direction. As I loaded it down more and more, the friction became less and less and less. There comes even a time that the friction becomes 0. I load it more and more and more, the friction flips over to the other side. The friction grows and grows and grows, fights a heroic battle to not make it go uphill, loses the battle at one point, reaches the maximum value, I put a little bit more on here, and it goes. So this frictional force is really having a rough time, starting off in this direction, slowly becoming less, becoming 0, changing direction, reaching a maximum, and finally losing the battle. Friction is often a pain in the neck, as we all know. Friction causes wear, it causes tear, and it costs fuel. There's a car, there's a lot of friction with the road. You pay for that, and people try to reduce friction with bearings and with lubrication. Oil. Water is an amazing lubricant. If it starts raining and there is a little bit of dust on the road, the friction coefficient between your tires and the road can become so low that you begin to hydroplane, and that you literally, that your friction coefficient goes almost to 0. It happened to me once, and it's no fun. It can happen instantaneously, particularly when the rain begins, in the very early part of the rain, when the road is dusty. So you get the water with a little bit of dust mixed. It's a very dangerous situation.